Hi, I'm Leo, this is DevOpsPod, and today we're going to put some code in AWS Lambda. So a couple of years ago, I wrote an API that would download a photo of the day from National Geographic website, crop it, and serve it to the world so you can use it as a wallpaper. But recently, the server it was running on was terminated, and I don't feel like setting up a new one. So what are the options? I still want those juicy photos on my desktop. First would be running another VM. Not an option, not fancy, temporary and expensive. Option 2, get a EC2, for example. As you can see, for the first 12 months after you sign up for your AWS account, you get the smallest machine there is for free. 750 hours is quite enough to run you for the month. But again, it's a waste. Then there are services like Heroku. For example, you can have a small dyno, basically a container that will run your application. But when you realize that you basically have to do a task once a day, any kind of VM or permanent application is kind of a waste. So there is Lambda. As we can see in the free tier of Amazon, Lambda is always free with 1 million requests per month. We need about 30. So basically every night our Lambda function will trigger, do the thing, and save things to AWS S3 bucket. Well, technically S3 is not always free. You see, it's only free for 12 months, and my 12 months are long gone. But if we check the calculator and realize that we are going to store 2 photos at any given moment, and let's say we have 3 devices that will download it, and basically it will result in about 1, maybe 1.5 gigs of traffic every month, we receive the total sum. I think we can afford that. So before we begin to code, we need a couple of things, specifically buckets. As you can see here, I have a couple of bowls, as I call them, because it's a small bucket. There's Lambda's bowl, it's empty right now, which will hold our code. Well, strictly speaking, you don't have to host your code in S3 bucket, but AWS recommends to use S3 if your function is more than 10 megabytes, I believe, and ours will be quite large. And there's TF bowl. It is a bucket for Terraform. So all the state will be here. I like to store my Terraform states in buckets or in Postgre or anywhere except my computer, because if I want to switch it or I lose it or whatever, my Terraform state is gone, and we don't want that. So which is why we are going to have our Terraform state here. Now to the function. Here we have a boilerplate. So first thing we're going to fetch stuff from the internet. So we're going to need a node fetch. And yes, I'm writing JavaScript. Sorry about that. Of course, we're going to have to store things in S3, which is why we need AWS SDK, and then the sharp to crop our images. Crucial part is this command. Usually when you write a Node.js application, you put all your dependencies in your package.json. Here we won't have any package.json because Lambda doesn't care about it. We'll have to bundle everything into a single zip file and push it to Lambda. As you can see, we'll have package lock, but that's unavoidable, and just that's it. So we'll have to install our dependencies for this platform. Because if you're developing on Mac or Windows or even different version of Linux, you will get into trouble because your function will not work, because Sharp uses C binders, which is platform specific. So if I just type npm install Sharp, it will install Sharp, it will work on my machine. And I don't really want it to work on my machine. So we're gonna have to specify to which platform, to which target we want to install all those things. Then we instantiate our S3 handler and call our bucket. This is the name of a bucket that will hold our pictures after we've done with them. And that's the all setup. Let me just paste code bit by bit. We'll just quickly run through it. So firstly, we are going to have to fetch gallery from National Geographic website. This is the gallery from the whole month, and if we'll visit this link, yes please, we're going to see huge JSON. That's basically all the photos of the day with the descriptions, authors, etc. for the whole month. Then we're going to have to figure out what date is today. For that, we'll create a date object And here we will construct a string with the same syntax as National Geographic JSON gives us. If we look closely, we see that this is their format of the date. So we're going to have to construct the same string. And since JavaScript date object doesn't have a full name of the month anywhere, we're going to have to create an array with all the names and refer the number of the month as an index. Then we're going to find our JSON of the day. As you can see, every day they're giving us a huge list of renditions. Those are basically the same picture with a different resolution. And we need the highest. So let's find the largest. We'll do it with reduce. We'll find the biggest width of all our renditions. Next up, we need to crop them. So we're going to do two crops. First one will be for the desktop, so it's 16 by 9. And the second for mobile, which will be whatever the height of the image is, and we'll just get a width about 70% of the height. I found it to be the best ratio to use on an Android device, so that when you swipe through your menus, through your home screens, you can still get this cool parallax effect. Next up, we construct parameters for S3 handler, so we can put our images into S3 bucket, and then we do it. As you can see, I'm constructing an array of those promises so that I can resolve them simultaneously, which will reduce the time that the function executes. It is important in Lambda. You have a limit for function execution. What are we going to have to do now? Now we have to zip it. Let's open up a terminal, go to our function directory, and zip it. It's done like this. It's essential that your index.js or whatever your file is called is in the root of the zip. Otherwise, Lambda will not find it, and then you're gonna have a bad time. As you can see, the zip file will be quite heavy. That's because of the sharp. Now to the fun part. We have our Terraform manifest. We're gonna have to create a bucket for our photos. As you can see, it's called the same as in the code. See? This name must be the same. Otherwise, your code will try to put things into a bucket that doesn't exist. We don't want that, right? We want this bucket to be public read. This policy, this file. Let me just open this file. Where is it? Here it is. This file tells it that in this bucket, it's really public read. Next, we're gonna have to create IAM role for Lambda. That's where Terraform gets tricky. You have to create a lot of resources for a single thing. Next, we're gonna have to attach this policy to the role that we've just created. Next, we're going to refer our S3 bucket. You see, this is data source. It's not a resource, it's a data source, which means that we want Terraform to know everything about the bucket with this name, which will give us information about this bucket. Well, here, technically, we don't really need it just because we only use the name. So we could just write Lambda's bowl here without any references, without any variables. But it's always a good idea to refer to an object that you've discovered, just because those might be dynamic too. Just in case you have a resource that's created in other Terraform manifest, or it's managed by other team, it's handled by a manifest that you don't have access to, but you know one thing about it, like the name, the CIDR of a network, or you name it. So this way, with this data AWS S3 bucket Lambda bowl, we can get bucket name, ARN policy, whatever you want to know about this bucket is here. So in this resource, we are uploading our zip file that we've just created to this bucket. Next, we're gonna create our function. That's the fun part. We have just uploaded a zip file to a bucket, so we're gonna have to refer this zip file into this bucket. Again, we don't want to use names, we want to use references, because if we change this name, for example, it will always be correct here. Otherwise, you'd have to correct things in multiple places. Then we specify the basic things for Lambda, like a role, what the handler is called, and as we can see, our handler is called handler. And the memory size. Bear in mind the default memory size for Lambda function is 128 megabytes. It's not gonna be enough. not nearly enough for image manipulation. And that one would help us greatly to update our function, because this source code hash will change every time we modify our zip file with the code. So it will change here in the Lambda function definition, which means it will update the function. If we don't add this line, the function will always use the old code. It will not reload it again, ever. And the runtime is Node.js 10 just because I said so. Now, we want to run this function every day, which is a cron job. Every day, let's say at 5 a.m., we want to run this function, do its thing, and sleep till the next night. The only way to create such a behavior in AWS is with CloudWatch event rule, which will be a cron every day at 5 a.m. do things. But to make Lambda run with this rule, we have to first create an alias. So Lambda has a concept of alias, which allows you to put a function in different workflows. It may come handy. In this case, we use it to allow CloudWatch to run this alias, and with the next resource we will allow CloudWatch to run Lambda function from CloudWatch events. Well, this stuff is quite generic. It's basically copy-paste from AWS documentation. And the last thing, we want to create a trigger which will trigger our function with a rule. Simple. Now let's see if it works. Let's go to our Terraform directory and try to Terraform apply. It should create quite a bit of things, so let's give it some time. Yes, please. Disclaimer: it's always a good idea to check what Terraform tells you here, so what it's gonna do. Here I know I have an empty state, so I don't care about anything. But usually it's a good idea to check what you're going to destroy. Now let's go to our S3, yes, why not, S3 management console, and check if our bucket was created. Yes, it is. Here it is. Now let's see Lambda. How's the function doing? Oh, we have a function. It's 38 megabytes. See? For files larger than 10 megabytes, consider uploading using Amazon S3, which we did. So here in the qualifiers, we can see our alias that is bound to CloudWatch events. Let's test it. Let's create an event. A test event would be Amazon CloudWatch. Let's call it something. Yep. We don't care about this stuff, we don't use it in our code, and press test. That took you a while. Duration is 2.5 seconds, so build duration is 2.5 seconds. It's totally fine, we will not exceed our limit ever. So memory size 256, used 143, see? 128 will not be enough. And actually I've tried the previous version of this code. It was using anywhere from 150 to 250. So 256 is a bit of a stretch. And let's check our bucket to see if the pictures are there. Pod. What do we have here? And here we have our pictures. There we go. Isn't it beautiful? And there you have it. A Lambda function that crops photos for you.
A few moments later.
Hi, it's me from the future. I've let our function run for a few days, and as you can see, it did synchronize everything we want every day. So there you have it. Feel free to use this code. It's going to be on a GitHub. I will link it below. Now, a bit of a legal disclaimer. You are not allowed to redistribute those photos. You're allowed to look at them, you're even allowed to download them, but you are not allowed to copy them and distribute them, which is why I'm going to shut this down, recreate it with my other account, so that you guys won't use the same link. If you want to set it up yourselves, now you know how. Now, I've been Leo, this was DevOps Spot. See ya!